Hello, everyone, and welcome to Traffic Corner Tuesday. My name is Nancy Crow, and I'm the Vice President of Marketing for SPAC Consulting and your host for today's session. Before we begin, I would like to remind everyone of a couple housekeeping details. First, please mute your mics. Muting your mic will minimize the background noise during the presentation, allowing everyone to hear the presenters clearly. And secondly, please join the conversation. Today's presentation is intended to be an interactive dialogue. I would encourage all attendees to feel free to ask questions or share your experience throughout the presentation. You no need to wait till the end. And just type your question and comment in the chat area, and we'll be happy to address your question throughout the presentation. Now I would like to introduce today's presenters. Bryant Fisek is the Vice President of SPAC Consulting and is also widely known in the transportation industry, having managed over 700 traffic engineering projects. He's a graduate of the University of Minnesota and an expert in Synchro, SimTraffic, Vistro, and vSim traffic modeling software packages, and he thrives on developing creative solutions to traffic and transportation issues. Bryant is a regular contributor on Mike on Traffic blog and a published author in industry publications, as well as co-author of several industry manuals. Also joining us today is Jonah Finkelstein. He is a traffic engineer with SPAC Enterprises, and he is an integral member working with all aspects of our traffic studies from data collection to forecasting, evaluations, and reports. Jonah specializes in traffic signal operations, including signal timing and traffic control design during the construction phase. He's also a graduate of the University of Minnesota, a member of the ITE's North Central Division, and a regular contributor on the Mike on Traffic blog. Please join me in welcoming Bryant and Jonah to today's session.
All right. Hello, everyone. Welcome back. Happy Valentine's Day. I hope everyone's having a good day so far. With me is Jonah, as Nancy mentioned. Mike is actually on vacation this week. He's somewhere on a nice cruise having fun, we hope at least. All right, following this session, we will have a guide available. It'll go through basically most of the information we have in here, but it's a quick little snapshot of this. When we get to the end, we'll tell you how to get that one, and so hang with us through everything. As we mentioned earlier, 14th today, this is our crash analysis at intersections and corridors, so we'll go through all that information today. A couple more is coming up on the 28th. These will be our live ones. We'll talk about large development parking requirements, and then on the 14th, we have our traffic signal warrants. So 2 more coming up as we move along, so hopefully you'll all be back and join us for those. All right, so let's dive into this crash analysis. So we'll start with the 5 W's, the who, what, when, where, why, or however order we want to take them. Obviously the who is going to be us or you. That's a pretty simple one to answer, just whoever is completing the work. Very easy.
The what is what are we doing? We're doing the crash analysis, and an important part about the crash analysis that we're going to be talking about here is that it's a reactive method. It's looking at it's looking into the past, what happened along specific corridors, intersections, and it's not forecasting what could happen based on roadway characteristics and commonalities between those characteristics.
Yeah, we do have some colleagues who try to look forward and look towards what characteristics make a section or an intersection dangerous and try to correct those. Like Jonah said, this is the reverse of that, looking backward, looking at that past history and saying what's happened, where do we see higher levels of incidents, and then taking that to move along and help and try to figure out what can be done.
The where was quickly covered when we were discussing the what, but the where here would be the crash analysis. We're completing our intersections along corridors, and those corridors, as we'll discuss a little bit later, will get broken down into smaller sections, but intersections and corridors.
The when part of it is when do you complete this analysis? And really it can be done anytime. We've done it as standalone studies, part of a safety study of an area. You can look at various things there. We have done crash analysis as part of our traffic impact studies or other types of traffic studies. And finally, just in comprehensive plans, when we are working for cities or counties, larger areas, as part of that regional view, it can be done there. So there's really, this can be applied anywhere, any type of study you're looking at, any type of traffic study. It's really, you know, trying to look back at what are the goals of the study, and does this fit into those goals, or what is being asked of what you're being done.
And finally, the why is to improve safety along a corridor, along a transportation system, and to help direct the resources, money, to where it's most needed. If we can remove crashes, if we can remove incidents from the road, we're going to help improve a lot along the corridor, improve safety, improve time, and it's
basically we want to get you home safely, so yes, to and from work. So anything we can do to help make sure that people get to where they want to go. All right, so shifting now into the next piece, which is obviously the why. This gets a little dry here, but we need to go through some key definitions. Let's put ourselves all on the same page, make sure we're all understanding some of the key terms that we're talking about. So the first one is just crash. What do we mean by crash? And this is just a collision. It could be between vehicles, could involve pedestrians, bicycles, any member of the traveling public. It's just basically there's an impact that has happened, and it has been reported into, usually through the police or other methods that can be done, but it gets recorded down as an incident has happened at a location.
The next, it is important here to mention that we want to call these crash and not an accident. Accidents imply that the collision could have been avoided or it happened by chance. We don't want to point fingers. We don't want to do any of this. So we're going to use the term crash because it's not our job to
assign blame, basically, yes. So, yep, good point.
The next term here, crash density. This is just simply the number of crashes that occur in the year. When we're doing an analysis, anywhere normally a 3 to 5 year analysis, you can just look at your total crashes and divide by the amount of years you're looking at.
Crash severity, this talks about the seriousness of the crash and the impact on the drivers. And so we typically subdivide this into several different categories. Didn't have that one down. So one would be your fatal crash, type K usually. Those are deaths that have occurred as a result of the crash. Incapacitating injury, those are type A crashes. That would be injuries from the crash serious enough to prevent normal activity for at least a day. So there's a lot of different things that could be the result in a type A. It could be blood loss, could be broken bones, just anything like that that is going to stop someone from their normal activity every day.
The next one is a non-incapacitating injury. This is one where injuries are evident at the scene, but they're not serious enough to prevent normal activity. Visual injuries here is cuts, bruising, limping. However, the person is still able to go on their daily activities.
Next one we have is a possible injury. This is a type C, and that's a non-visible injury. So you don't see anything visible, but the person or who's ever impacted by it complains of pain, or there has been some momentary unconsciousness. So it could be headaches, backache, something that's, again, not visible, but the person is saying something doesn't feel right, and so it is listed down as a possible injury.
And finally, a property damage crash is a type PD or PDO, and these are crashes where there's no injuries, no person is injured from the crash, only injury to the vehicles, or public-private property.
Those are the most common, obviously. Most crashes don't result in injury. We hope they don't result in injury. So usually at the ones we're looking at, that'll be your highest number, is these property damage only. All right, so next term, observed crash rate. So this is a calculated term, or a calculated number. It measures the number of crashes controlling for the exposure at a location. So if it's an intersection, it's controlling for the traffic volume. If it's a section, it's controlling for the distance, and then the time as well. So these are it's basically a way to say, okay, if I have 5 crashes at an intersection over here and 5 crashes over there, are they the same? Well, not necessarily. So you would try to normalize it through the crash rate and say, and apply the volume and the time and all those factors to really figure out the ones between, or to compare between them, compare that apples to apples. I see there are a couple questions in our chat, and I think we're going to hit those a little later, so I'm going to leave those right there, and we'll continue through the terms, and I'll try to make sure we get back to those questions in a little bit here.
Next, we have the critical crash rate. This is a statistical threshold for screening locations, and it helps us determine if the observed crash rate is above a statistical range that we expect to occur. When a observed crash rate exceeds the critical crash rate, it does indicate that there's a safety concern at the intersection or at the corridor, and that further analysis should be required and should be pursued to figure out what is truly causing this issue and to address the issue going forward.
And I'm sorry, as I look back, I reread the chat question, and I think it is relevant here, relevant to the severity. The question is, what is the time limit from the exact time of the crash to a death of the person or the involved person for it to be considered a fatal crash? And this one, it is talked about in our MnDOT books, and it might be different per state. I'm trying to remember off the top of my head, and boy, I want to say 30 days on that, but that's something that we're going to have to check back on, and we'll get that answer, and we'll put that in with the rest of the presentation information when we send that back out. So very good question. Unfortunately, I don't have the answer right off the top of my head. All right, coming back to key definitions, our last one we have is this critical index, and that is simply the observed crash rate divided by the critical crash rate. It's just the ratio of the two, and it's an easy way to look at it and say, do we think we have an issue at this location? So again, just a ratio is what we're looking at there. All right, so with those key ones, let's get into some formulas now. So specifically crash rate. So let's start with that, and the crash rate is the number of crashes divided by the exposure. So this is, like we talked about, the way to normalize it between locations and come to a comparable number.
And so when we say the exposure in that equation, we're talking about there's two different calculations formulas there, depending if you're looking at a intersection or a corridor. But the exposure for an intersection will be the number of days multiplied by the entering volume divided by 1 million vehicles. And the entering volume here, there's a few ways to get it. If you have intersection turning movement counts, it would just be your daily sum there. Or if turning movement counts weren't collected, ADTs can be collected. However, if we have ADTs, if we're looking at a 4-leg intersection and we have ADTs on all 4 legs, you would need to add up those 4 ADTs and divide by 2 to make sure that we're not doubling up on that volume. And then also sometimes there's situations where you'll only have ADTs along 1 ADT for the north-south leg and 1 ADT for the east-west leg. And in that situation, you can just add those ADTs up, and you do not need to divide by the 2, which we'd have to if we had all 4 legs. Then for a corridor, you're going to look at the number of days by the average daily traffic, the ADT, multiply that by the section length, and then divide by 1,000,000 vehicles.
So the million in this case is just a standard factor. That's going to help us to, again, when we normalize it and we talk about it, we get to a crash rate. It'll be per million entering vehicles for the intersection or per million vehicle miles. So there's, it's just a way to, again, normalize it. You want to put that number in there to make sure you have something that's readable, like a 0.5 or a 1.2 or something. If we don't have that factor in there, typically those numbers would get so small it doesn't make sense to do that. So yeah. All right. So let's see. So moving on to the next one, the critical crash rate. This one gets a little tricky, and you do need some other information for it. But what you're going to start with is your statewide average. So if you have an average for the intersection or the type of intersection you're looking at or the corridor, similar corridor, you take that average. Your next one is this, so statewide average plus, this is a K, this is a confidence interval factor, and we'll discuss that in a second, but you take this one times by the square root of your statewide average divided by the exposure, and then finally plus 0.5 over exposure. So as we talked about in the definitions, this critical crash rate is a statistically valid threshold. So this is looking at it and saying there's, at any location, intersection, or section, based on its characteristics, you're going to have crashes there. Most likely you have crashes there, and there's a range that it could happen. So it takes kind of that plus and minus around the average and says if you happen to have, and that's where then you would come back and look at this critical crash or critical index, because then as you put that ratio together, if your crash rate that you calculated is much higher than your critical crash rate, so it's above that, that's where you're going to see that you have issues. That's going to say you have a statistically valid amount of crashes above what you would normally expect at a location. So that's really the comparison we're looking for, this last index. Once we go through these formulas, put them together, we get to that critical index. If it's 1 or lower, we're saying it's within our normal pattern that we would expect. If it's higher than 1, that's where we would say we should look into these a little bit deeper, because it's likely there's something going on that we might be able to correct. All right, so the confidence interval factor, what we normally use for that is a constant, a 2.576, and that gives us a 99.5% confidence interval. So that's, as we're weighting it, as we're looking at that critical crash rate, that's the factor that we use to give us that confidence. There are some different ones if you want to go to a lower level of confidence. I don't have those off the top of my head, but typically we would try to go to that high confidence, which gives us that upper bound that says, boy, if we're above this, we should really be looking at that intersection. Okay, so turning from the formulas then, this is going to get into a little bit of the Minnesota way to do it, but I also think this is valid, and we'll show you some sheets here in a little bit that you could take, even if you're not in Minnesota, if you have some of this average, if you have some of the average values, then you'll be able to sub that information in and localize it to your location, and then the crash rate and the other formulas will stay the same, but it'll take your information. So, like I said, specific to Minnesota, but also can be used for these other areas. So as we look at that, we go, we've got the basic information. What else do we need to know about the intersection? So here's where some of those characteristics come in.
When analyzing intersection crash analysis, the first thing we'll look into is the traffic control device. Here we're just talking, is it a traffic signal, stop sign controlled, roundabout? The rates, the averages will change depending on what type of traffic control device is in the field and we're analyzing.
And that stop sign control, you want to make sure, is it two-way, is it all-way, that type of thing. So those are the basic ones, basically your traditional traffic control.
The environment is also important. This will change the rates. For Minnesota, we look at 4 total. We look at the urban, suburban, city bypass, and rural. Again, those, depending on what environment you're in, there's different roadway characteristics and different roadway characteristics which will affect how people drive and where crashes occur. We're going to see more intersection crashes in an urban area than in a rural area, as there's more intersections and more traffic.
Stepping back, we had another question that we'll just hit right away. It's, when would it be appropriate to use the crash frequency or the crash density versus crash rate in this situation? What we typically see is if you have a low volume intersection, for example, 1 or 2 crashes can really drive that crash rate up, even though it's only 1 or 2 crashes. That's a random event in my mind. So what we would typically see is you pick some frequency to say if it's below, say, 5 crashes at an intersection, you're not going to worry about it because that could happen. That could be random events. It really doesn't make a difference. So then you focus on those intersections that are above that frequency to then look at the crash rate and say, okay, I know I have 10 at this one. Now I calculate the crash rate to see, are those 10 an issue, or is that within the normal range of expectations? So that's how we would use the crash frequency, and that can be the crash frequency and the crash rate, and that can be applied again to both intersections and corridors.
The next thing we'll look at is the speed limit. This can either be the posted speed limit or the 85th percentile speed. It is important here to note that a lot of us rely on Google Earth, Google Images, things like that to figure out the lane configuration, the speed limit, things like that. It is always good to go out there and do a field visit to see what is actually out there in the field. It can change pretty quickly, and oftentimes there will be some discrepancies between Google Earth and what's actually out in the field.
Last one, the total entered volume, we talked about that with the rates, so just figuring that out. And then, again, for Minnesota, the volume on the highest leg, that is, that just helps sets the characteristics as we're looking at them. So those are all what we need for an intersection. So quickly turning to the section.
The length of the corridor, the length of the section that we're analyzing, because when we're doing a corridor analysis, we'll have to break it down into smaller sections, which we break out from these following characteristics.
And just for that length, we normalize it in per mile. So by having that length, whether it's a quarter of a mile or 2 miles, you break that down. So you do need that length for the rates and for the other information. Volume, we talked about. Environment, this is similar to the intersection, but really just urban, suburban, or rural. Those are the 3 categories we use. Those are where we would see differences between the crash characteristics.
The roadway designation, whether it's a freeway, expressway, or just a conventional city roadway. The number of lanes, this is the total lanes each way along this section. So 2 lanes both way, 4-lane section. The median type is also important, whether it's not divided or there's no median, is a barrier, a curb, a divided, or a depressed median.
All right, so in our last few minutes here, let's get into a project we had. This is in St. Louis Park, and this is Minnetonka Boulevard. You can see we had a big run. This is just under a 4-mile corridor. So pretty long in terms of looking at all the crashes, and everything goes right across the city. This was an important corridor that they wanted us to look at and try to identify where are some of those hot spots, where might we be seeing problems? What is it looking like today? So with that long a corridor, you can imagine how the characteristics change as you go from one section to the other. So it's really not appropriate in this case to just look at that whole corridor. This is where we would break it down into sections, and so that's what we did here. Looking at that overall corridor, we split it into several sections based on the characteristics of it. The blue lines here show our break, and actually at this end, our line wasn't drawn very well, but the road actually splits, so you have a one-way, almost one-way pairs, and so this last one was split out into 2 segments. So we ended up with 9 segments here for this corridor that we looked at to really get into those crashes. And we talked about the different characteristics. So for each of those segments, we went through, we measured the length, we got the volume, what the environment, so all those different characteristics. So let's quickly kind of go through. This is just Google Maps, so you can see the corridor we've got there running all the way across. So this was where we started for our information, going through, zooming in, looking at the number of lanes, using Street View where appropriate, try to help us figure out where those breaks were. As Jonah said, it's also important for us to get out there and make sure that we confirmed everything we were viewing here, just make sure everything's correct. That's worst thing you can do is put in some wrong information and have your client or the city come back and say that's not true. And then you can also measure off of here too, and that's where we got some of those lanes.
The next tool here, this is again specific for Minnesota. This is the MnDOT traffic forecasting and analysis page. And here is a great place where you can get the ADTs for all of Minnesota, but along any corridor as well. We're able to jump in there, find which map we want to look at, and then you can pull up those ADTs. There's also the traffic mapping tool, which is a more interactive map, but will present those ADTs along each roadway and approach to use in the analysis.
Yep, so this was, usually most states have something, some cities might. If you're not going out and counting everything, you can just grab the daily volumes from there.
Again, much like a site visit is needed, it is good to have those turning movement counts, but it's also great to have that ADT analysis information as well, as it is normalized and kind of the accepted value along that corridor. So both are valid tools to use.
All right, so again, like I said, this is specific to MnDOT. This is our traffic safety, but this is where we pull a lot of information. This is where we get those spreadsheets we were talking about. You can pull those up. Those will help you calculate the different things. We'll go through that in a second. But right here, this is our crash mapping analysis tool, and it allows us to go in. This is our corridor right along, and you can see all the red dots are crashes. I haven't filtered anything out here, but this is the tool that we use. It allows us to go in. We can go in and select the segments we want. We can draw around the segments we want. We can come in and filter the data. I know Iowa has something like, I know a number of states have something like this. So if you're not getting the data specifically from your client, whether it's a city or whoever, hopefully you have a tool like this. You can come in and grab that stuff independently. So let's switch quickly, the last minute here. So this is what the intersection sheet looks like, and this is where I was talking about we've got our 3, 5, 10 years all provided by MnDOT for our averages, conventional road, or crash rate, severity rate. It's got all this information in there. So if you have that for your area, not in Minnesota, you would be able to come in here and adjust these and use this spreadsheet as well. These are some of the definitions so you can see what's going on in there, and then finally we get to the calculator. This is where we would put the information in. So pull down menus on some of them, just how much we're looking at there. You would enter in the crashes by types, put in your volume, traffic control device, what your area is, put the speed limit in, and then it comes down and it does all the calculations for you, the crash rate you're observed, what that average is, the critical rate, and the critical index.
The corridor green sheet is very similar. The main difference here, the statewide averages will be slightly different. The definitions will be slightly different, just specific to this sheet. But again, the most important tab here is the manual calculator, where we'll put in our crash data information, the amount of years. One important drop down here is if the junctions are included. When doing a corridor analysis, some people will remove intersection crashes. And if that is the case, you need to make sure that this one is toggled to no if you're not including those crashes. And then again, much like the intersection sheet, you're going to enter your K, A, B, C, and property damage crashes, as well as the characteristics of the roadway in that adjacent tab there. And then it'll output your crash rates and let you know. And then the bottom two boxes here show the observed statewide average, critical rate, and most importantly, that critical index, which is, again, just a great way to show that, yes, we're seeing an issue here when it's above 1, or no, we aren't seeing an issue here when we're seeing indexes below 1.
All right, so we are at the end of our time here. So I want to just say a quick thank you for everybody for attending. We hope this has been some useful information for you. Here's that free guide. Again, it's going to go through basically the similar information. You can get that information by texting or emailing Nancy as shown on the screen. Also, feel free to jump off here, but we will hang on a few minutes. I know we kind of ran out of time for more of the questions. So we'll try to, and looks like there are a couple more, so I'll try to go through those now. But again, thanks everybody for attending. We'll keep recording. We will plug this on our YouTube channel as well, so you can come back later if you need and hear the questions. So again, thanks, and let's turn to those questions now. All right, bear with me as I scroll back through here.
So we see a question here that's asking if when looking at sections to include intersections, or are we only looking in between intersections? And again, this just depends on how the engineer prefers to do it. And again, importantly with that, in the section, in the corridor analysis sheet, whether you're going to toggle on or off the intersection crashes included.
We have the luxury in Minnesota of having it both ways, so we can do it either way based on what we're trying to do. Personally, I do like to look at non-junction, take the intersections out, and then look at the intersections separately, because that can really identify whether you have an intersection problem or a corridor problem and try to focus in on your improvements. So that's one reason to separate the two. Next question, in what situation would you separate sections by horizontal or vertical curvature? That's something that you could do on your own. Again, it's in the spreadsheets we're looking at. That's not something that's entered in, but that could be something that you manually do and say, okay, I know I've got a curve from this location to this location, so I'm going to pull that information out separately and just look at it to see if there is an issue there. So you don't have to go specifically by the characteristics that we listed here. Those were just easy ones to identify and easy ones to look at. So that's why we did it that way. That doesn't mean you can't break that down into even smaller characteristics.
We have a question here that's asking when ADT on all legs isn't available and we only have ADT on the major approach, is it appropriate to use the major leg ADT in the exposure calculations? Yeah. It's a little bit of a tough one. It wouldn't be grabbing a full picture of the intersection. The important thing there is knowing how many vehicles are entering the intersection so that we can get that correct rate. So if we don't have all 4 legs or however many approaches we have, if we're not able to get an appropriate full view of that volume, one of the cases where the dreaded engineering judgment would come into play.
Yes.
And when you do know an area, you're able to make some better assumptions. You could probably parse out some pretty good or sufficient data to get an idea of what's going on there. But that might be a situation as well where it would be appropriate to look at the number of crashes and no longer the rates, as that rate may be skewed by the volume that we're using.
The other thing you could do is just use the major approach and figure out what that rate is. Because if your rate is way below the state average, adding in more volume is going to drive it lower. So it can be kind of a screening that you use with that caveat. So if you are already below the statewide average, adding more volume, like I said, looking at those formulas will drive that down. You know you're safe. If you're right at the average, right at the critical rate, that's where you may want to get more information. Or if you're above, that's where you might want to take that next step of saying, okay, let's really get the full volume of that intersection so we can calculate it for real. So there is a way to do it knowing that there's a caveat with it as well. Next question I see is, what is the next step after the initial corridor analysis? So just like we said, the first step is going through this process, trying to figure out, is there an issue to begin with, and how severe is it? And then once that's determined and you know where to deploy your resources, that's the next step to me would be then looking in more detail about those crashes and trying to figure out what's happening. Do you see any trends? Are all the crashes happening at night? Are they all in one direction or the other? Is it in the winter? So there's a lot of different things you can look at, and it's really based on the results of that next step analysis of the crashes that is going to help you develop those countermeasures. So if they are all at night, maybe we need lighting to help people see better. If they're all in the winter, maybe this needs to become a priority route for plowing or salting to make sure it's not slick. Or is there something else going on that's causing ice on the road? So in terms of further analysis, it's really going to depend on what you're trying to find there. The next step of looking specifically at the crashes, depending on how many crashes there are, that could be a very simple hour or less process of just going through a handful and looking at all those characteristics. Or if you have a long corridor, it may take you half a day to a day to really separate those out and look at what's going on there. All right, I think we're through all the questions. I did see a general one of professional development hours, and we don't provide any certificates based on this, but that doesn't mean you can't use this. It's up to your own reporting standards as far as I know, and I think there's some valuable information here, and I think people can feel free to use this as part of it. So I know I've referenced this on the teaching end of it to give us some credits for my license. So hopefully that answers that.
And we will also look into the earlier question about the time from what is considered a fatal crash, how long after a crash occurs, when a death occurs, how long can those be separated. So we will make sure we get that posted in here before we add it to the YouTube channel.
And our next one is on the 28th, so 2 weeks from today, and I have it listed as signal warrants. I saw I had that flipped in the other one. So I'm not sure what our topic will be, but we'll definitely be back here in 2 weeks. So hopefully you'll join us again. So with that, I think we're going to end the presentation. Thanks for those who stuck with us, and like I said, hope to see you in a couple weeks. Have a great day.
Thank you.